Space, the final great unknown. NASA's mission to uncover the secrets of humanity's last frontier, to pursue new knowledge and understanding. Godspeed, John Glenn, and to guide us toward a peaceful and united future in space. The vehicle has touched down. This two-part film will examine 10 of NASA's most remarkable achievements in space and science and show how they have continuously shaped the way we live on Earth and how we understand our place in the universe. That's one small step for man, one giant leap for mankind. Human beings can direct their ambitions toward the most unlikely and the most daring of endeavors. It was the essential first step to get an American into space, and it succeeded. The International Space Station is truly a marvel of space engineering. The Hubble Space Telescope is a one-of-a-kind instrument. Pathfinder did indicate that Mars may have supported life in its early history. With the right funding, the right expertise, and the right public backing, we can accomplish anything and go anywhere. For the eyes of the world, absolutely extraordinary. Now look into space. Okay, here we go. To the moon and to the planets beyond. Liftoff, and we set sail on this new sea to unravel these mysteries, to solve them for the benefit of all humanity. When the Soviets launched the Sputnik satellite in 1957, deep concern was raised within the US government regarding the technological advancement of their Cold War rival. It was evident that a federal body to lead American space efforts was necessary, and in 1958, the National Aeronautics and Space Administration, known as NASA, was established. But despite its Cold War origins, NASA was formed as a distinctly civilian agency with a focus on the peaceful exploration of space and science. President Eisenhower wanted a space program built on science and technology, not on the military occupation of space. His motto was "Space for Peace." He was profoundly concerned that if left unchecked, the military would claim space and seize the advantage. Had that happened, none of the great achievements in science or engineering that captivated the world would ever have come to pass. Enshrined in NASA's mandate is international cooperation and the open sharing of scientific data impossible under military leadership. Thanks to Eisenhower's forward-thinking administration, NASA has served as the world's foremost manned and unmanned space research agency since the late 1950s, setting the standard for all current and future spacefaring nations. Ladies and gentlemen, today we are introducing to you and to the world these 7 men who have been selected to begin training for orbital spaceflight. These, ladies and gentlemen, are the nation's Mercury astronauts. On April 9th, 1959, NASA unveiled to the world the astronauts chosen to fly Project Mercury, America's first human space program. Known as the Mercury 7, these men instantly became national heroes, ready to compete with the Soviet Union in the race to space. Project Mercury's primary goal was to place a solo human into Earth orbit, and the first mission assigned to pursue this objective was named Freedom 7. Freedom 7 was America's first venture into human spaceflight, and it came at a particularly challenging moment in time, because just 3 weeks before its launch, Russia had successfully sent Yuri Gagarin into space, making him the first human to do so. The US was already falling behind in the space race, earning it a negative reputation internationally. It desperately needed a positive story, and Freedom 7 delivered that story. Of the Mercury 7, astronaut Alan Shepard was selected to become the first American to fly in space. He would pilot the Mercury Redstone launch vehicle, a hybrid of a US Army ballistic missile and a research and development rocket modified for human flight. Finally, on May 5th, 1961, Al Shepard departed Cape Canaveral and carried the United States into a new era of manned space exploration. Flight. This is EMO. Go ahead, EMO. All subsystems start green. Roger. Understood. All systems green. It's 60 seconds. Counting. Status check. Pressurization. Tanks good. You are go. Water systems go. T-minus 30 seconds. Mercury capsule. All pre-launch panel lights are correct. The ready light is on. T-minus 15 seconds. Mercury umbilical clear. Mercury lights on. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine start. Ignition. All right. Liftoff, and the clock has started. This is Freedom 7, reading you loud and clear. Fuel is go. 1, 2, G. Cabin at 14 pounds per square inches. Oxygen is go. All systems are go. Freedom 7 with astronaut Alan B. Shepard reports. Fuel system is go. Oxygen go. All systems go. Astronaut Alan B. Shepard is performing like a test pilot, relaying facts and figures, reporting procedures with the precise technical manner of a test pilot. Trajectory looks good. Beautiful view. Freedom 7's suborbital flight lasted 15 minutes and followed a parabolic trajectory, arcing across the Earth's surface, before landing in the ocean 302 miles downrange. The primary scientific objective of Project Mercury was to assess human capability in the space environment and understand the conditions under which astronauts would need to operate. Unlike Yuri Gagarin's flight, which was essentially automated, Gagarin had the theoretical ability to control the spacecraft, but did not. Shepard's flight allowed him to exercise real control. Pilot reports assuming retro attitude, initiating retro fire sequence. Pilot reports mission very smooth. During the early stage of the mission, he was able to take manual control of the spacecraft and fire the attitude control thrusters to adjust its orientation. He's going to hand control movements now. Switching to manual control of the pitch attitude. So Shepard genuinely assumed real control of the spacecraft. He was not just along for the ride. He was not simply a passenger. After re-entry, the Freedom 7 capsule descended by parachute into the Atlantic Ocean, with Al Shepard paving the way for every NASA astronaut and manned mission that followed. The US was desperate to get into space. With Al Shepard, it was a suborbital flight, but it required tremendous courage from him and from everyone involved. And it was clearly right at the very beginning like that. It seems so straightforward now, sitting atop what is essentially an intercontinental ballistic missile, lighting the fuse and collecting him at the other end. But it was the essential first step to get an American into space. And it worked. And it was a phenomenal achievement for him and the entire team. The initial Mercury manned spaceflight certainly helped restore morale in America among those who felt the Russians were surging ahead, that the US had been overtaken by Sputnik and then by Gagarin. In the opening months of a president who had criticized his predecessor for standing idle while the Russians raced into the future. So it was crucial to rebuild American pride and ignite a can-do spirit, so that weeks later, when Kennedy announced the decision to go to the moon, people could believe it. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. Freedom 7 was a vital foundation of Kennedy's lunar program, a program that had been decided even before Alan Shepard first went into orbit. The announcement of that decision had been deliberately delayed until after Shepard's flight on May 5th, 1961. Freedom 7 had to happen for Kennedy's commitment to go to the moon to be publicly declared and fully funded. Without it, we might not have reached the moon even now. Freedom 7 was only the beginning of Al Shepard's spaceflight career. He later served as chief of the astronaut office, and then in 1971 flew to the moon as commander of Apollo 14. Okay, Al, we can see you coming down the ladder right now. Old man, it's been a long way, but we're here. Human spaceflight has changed enormously since 1961. Today's missions are complex, multi-crew, multinational endeavors carried out in the spirit of international collaboration. But the legacy of Freedom 7, Al Shepard, and the pioneering Mercury project will be honored every time NASA launches humans into space. Godspeed, John Glenn. Roger, the clock is running. We're underway. Oh, that view is tremendous. Beautiful. After President Kennedy announced the plan to land Americans on the moon by the end of the 1960s, it quickly became clear to NASA that a follow-on program to Project Mercury was necessary to develop the techniques required to support these future lunar missions. NASA announced its second human spaceflight program, known as Project Gemini, in January 1962. Gemini would serve as the bridge between the Mercury and Apollo programs, with the key objectives of demonstrating the endurance of astronauts and spacecraft for the extended duration spaceflight required to travel to the moon and back. Flights to the moon would take more than a week to complete, so one of Gemini's central goals was to establish the ability of humans to withstand long-duration spaceflight and understand the physiological effects of spending that length of time in a zero-gravity environment. Project Gemini would also develop techniques for rendezvous and docking spacecraft in orbit, refine atmospheric re-entry and splashdown procedures to ensure precise landing sites were reached, and perfect the practice of spacewalking. If an astronaut is to walk on the surface of the moon, they must first leave the safety of the spacecraft. Gemini astronauts were the first to train for these specialized spacewalks. Gemini was one of the stepping stones to the moon, and the whole purpose of exiting the capsule and performing a spacewalk was that it was understood this would be necessary. Learning to operate outside the spacecraft was a critical element of reaching the moon. It remains an essential part of what we do at the space station today and always will be. EVA stands for extravehicular activity, meaning the astronaut is working outside the spacecraft in open space. It was a critical part of the preparations for the lunar landing because a core objective of that landing was to operate outside the spacecraft to exit the lunar module and work on the lunar surface. It was also vitally important to be able to leave the spacecraft if any repairs were needed, so that an astronaut could go outside, retrieve materials, or fix problems on the exterior. While it was obviously hoped that would never be necessary, it was important to demonstrate it was possible. The first NASA mission to attempt an EVA was Gemini 4, the second crewed mission of the Gemini program. Gemini 4, flown by astronauts Jim McDivitt and Ed White, was assigned the task of proving the US was gaining ground on the early Soviet achievements. Using Project Gemini's new launch vehicle, the Gemini Titan II rocket, McDivitt and White departed Cape Canaveral on June 3rd, 1965.5, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. We have a liftoff at 16 minutes after the hour, climbing very nicely. We have a roll program initiated. We have staging, and it's been confirmed here on the ground. Thrust looks good. Thrust looks good on the second stage. And McDivitt, in a very calm voice, said, "It looks great up here." After their third orbit of the Earth, Ed White opened the hatch of the Gemini capsule and made history, becoming the first American to walk in space. Okay, I'm separating from the spacecraft. My feet are out. Okay, I'm out. Tethered to the spacecraft, Ed White floated freely 200 miles above the Earth, traveling at 17,000 miles per hour. Okay, I'm coming over. You see me yet? I feel like $1 million. This is the greatest experience. It's just tremendous. The footage of Ed White's EVA is among the most recognizable and iconic imagery from the early era of the space program. Up until that point, astronauts had observed everything, either through periscopes in the early Mercury days or through relatively small cabin windows. And here was an astronaut opening the door in orbit and moving out into open space with a completely unobstructed view of the Earth and the spacecraft just a wide visor giving him the full panorama. It was such an inspiring moment, a phenomenal and genuinely courageous achievement. If you imagine simply opening the door of a spacecraft and stepping out, that was an extraordinary thing to do. Ed White's EVA was proof that the United States was closing the gap with the early Soviet successes and that NASA's training and hardware were capable of winning the space race to the moon. However, NASA's first spacewalk didn't go entirely to plan. A communications failure meant Mission Control could not establish radio contact with Gemini 4 for most of the EVA. Gemini 4, Houston Capcom. Gemini 4, Houston Capcom. Ground control was deeply concerned because the astronauts were losing track of time. Personnel on the ground were desperately trying to reach the astronauts to end the spacewalk. Flight controllers were worried that if Gemini 4 fell behind the mission timeline, Ed White could find himself walking in space on the night side of the Earth. In total darkness, maneuvering back to the safety of the capsule would be extremely difficult. Gemini 4, Houston Capcom. Eventually, Jim McDivitt identified and corrected an incorrect switch configuration inside the capsule, restoring communication with Mission Control. And as he did so, McDivitt said, "We better find out what Capcom thinks, see what the flight trackers have to say." Capcom received the signal, and the immediate response was, "The flight director says get back in. This is Jim. Got any message for us?" Gemini 4, get back in. Okay. The message from Capcom was essentially Mission Control ordering the astronauts to stop and return to the capsule. Roger. We've been trying to reach you for a while here. No, back. Come on. I'm coming. Okay. Ed White's EVA lasted just 23 minutes, but NASA learned a critical lesson about how humans function in the vacuum of space. NASA found that EVA is genuinely difficult. Working in a spacesuit, which is extremely restrictive, is physically exhausting. The subsequent Gemini EVAs all ended with astronauts returning to the capsule in an overheated and depleted state. It wasn't until 8 Gemini missions later that astronaut Buzz Aldrin, who would go on to walk on the moon alongside Neil Armstrong, conducted the first truly comprehensive EVA. Gemini 12, Houston Capcom, 1-minute EVA record. Beautiful job. His success was attributed in large part to his background as a scuba diver. Aldrin pioneered the technique of underwater neutral buoyancy training, which simulates conditions similar to those encountered while working in space. Project Gemini flew 10 crewed missions between 1965 and 1966, firmly placing the United States ahead of the Soviets in the Cold War space race. And the neutral buoyancy training developed during Gemini remains a core element of astronaut preparation to this day, underpinning the success of every NASA EVA since. NASA's first close-up observations of Mars were carried out by the Mariner and Viking programs during the 1960s and 70s. These landmark missions provided our first views of the mysterious red planet, both from orbit and from its surface. The exploration of Mars can be considered one of NASA's greatest achievements. The early period of that exploration, from 1965 to the late 1970s, saw NASA achieve the first landing on the Martian surface, with 2 laboratories that extensively analyzed, excavated, and photographed the terrain at 2 separate sites. Following those pioneering missions of the 60S and 70S, there was a pause in American Mars exploration. It was only in the early 1990s that NASA began developing a new generation of landers and rovers capable of traversing the Martian surface and visiting multiple locations. We had seen with Apollo how the lunar roving vehicle had been able to cover various areas of geological interest around a common site. We wanted to replicate that on Mars, make it mobile, not just a stationary lander. And it aligns entirely with the human spirit. You climb one hill, you see another, and want to climb that too. And that is exactly what these rovers are built to do. After almost 2 decades, NASA finally returned to the Red Planet in 1997 with the Mars Pathfinder mission. Pathfinder's goal was to cost-effectively deploy the first free-ranging wheeled robotic rover onto the Martian surface, with the mission carrying a suite of scientific instruments to study the Martian atmosphere, climate, and geology. After a 309 million-mile journey through space, the Pathfinder spacecraft arrived at Mars in July 1997. But in addition to its scientific goals, Pathfinder was set to test a bold new descent and landing system. The approach used to get not just a lander but a rover safely onto Mars. If you had read about it in a book 10 years earlier, you would have said this is crazy. This is science fiction. If Pathfinder could successfully demonstrate this new technology, it would permanently transform the way scientific probes are delivered to a planet's surface. The spacecraft entered the Martian atmosphere at 4 miles per second, heating up to more than 1,000 degrees centigrade, but slowing enough for parachutes to deploy. Mars's atmosphere is so thin that even with these massive supersonic parachutes, the craft was still moving faster than a speeding car on a highway. So, for the final stage of landing, the lander and rover were encased within a large assembly of airbags. When Pathfinder struck the Martian surface, the first thing it did was bounce. In Mars's much lower gravity, those bounces continued more than 15 inches total. When the spacecraft finally came to rest, it had only a limited window of battery power to deflate its airbags and orient itself correctly. If any single link in that chain had broken, the mission would have been lost. And we must remember that at the time, fewer than half of all missions dispatched to Mars had ended in success. A tremendous amount of new technology was riding on Pathfinder's outcome. Now on the Martian surface, the Pathfinder lander opened, releasing the rover to begin its scientific work. Mars Pathfinder was the first rover exploration of the Martian surface. The Pathfinder lander itself set down in a region called Ares Vallis in the northern plains of Mars. A small rover then rolled off and explored the nearby rocks and soils around the landing site. The data returned by the Pathfinder mission has begun to genuinely transform our understanding of Mars's geological past. The chemical analysis of different rocks revealed insights into Mars's volcanic history, showing that the planet had a diverse range of volcanic activity, from effusive lavas similar to those seen in Hawaii and Iceland, to more evolved forms of magmatism, possibly linked to more explosive volcanic structures. This was truly unexpected for the Martian surface. Pathfinder was not designed to test for microbial life, or to determine whether anything ever lived on Mars in the past or present. It was a geological exploration mission. However, Pathfinder did suggest that Mars may have had a warmer, wetter past, and where there is water, there is always the potential for life. No life was detected, but it provided crucial evidence that Mars may once have been wetter and warmer, and may potentially have supported life in its early history. Collecting over 8 million measurements, more than 16,500 images, and outlasting its designed lifespan by 12 times, Pathfinder's extraordinary volume of data significantly reshaped many long-standing scientific theories about the Red Planet. But perhaps Pathfinder's greatest contribution is the path it cleared for NASA's continued exploration of Mars. Pathfinder led to spirit and opportunity in the new century. They landed in 2004, and Opportunity spent more than 10 years traversing the surface, visiting different sites, and covering over 25 kilometers, a mission designed to last 3 months that endured for more than a decade. That was followed by an extraordinary new level of capability with the 1-ton Curiosity rover. Lowered by a sky crane, the new method we will use to deliver large landers and rovers to Mars. And in 2020, a vehicle of the same design with different instruments would gather samples and deposit them at a location for a future lander to collect for return to Earth. That itself would be the precursor to the first human footsteps on the Red Planet, which could realistically happen in the 2030s. What we really need on Mars is to send a geologist, because a rover can only see what is in its path. It cannot make real-time decisions. A geologist on Mars could do exactly that. Take, for example, the Apollo 17 mission, where Harrison Schmitt, a geologist, went to the moon. What he was able to do far better than any robotic system is to say, actually, we don't want those rocks. There's one we should investigate. There's one we should bring back. To make genuine human decisions in the moment. But the missing link that made our modern rovers possible was the Pathfinder mission. What a remarkable legacy to leave behind. What NASA accomplished in that landmark summer of 1997, deploying a Martian rover for the first time, truly paved the way for the successes and the future explorations that the agency is now planning for the Red Planet. The exploration rovers operating on the surface of Mars continue to rewrite the scientific understanding of the Red Planet. But it is clear that what NASA began in 1997 with the Pathfinder mission will ultimately lead to an international human expedition to set foot on Mars. During the early 1970s, it became increasingly clear to NASA and the broader scientific community that much more needed to be understood about the 4 outer planets that dominate our solar system: Jupiter, Saturn, Uranus, and Neptune. If more could be learned about these gas giants, it could unlock secrets to the history and formation of our Earth and the solar system. Exploring the solar system in which we live allows us to better understand how our own Earth was formed. We are intrinsically part of that solar system. We therefore need to understand more about the planets that surround us and how we fit into this remarkable corner of the universe. To understand our position in the evolution of the solar system, let alone the galaxy, we needed to venture beyond the asteroid belt and truly come to terms with what those planets were about. That was Voyager. As originally envisioned, the Voyager program was a sequence of missions that would send a fleet of spacecraft to explore our outer solar system. But due to budget constraints, the program was scaled back to the 2 spacecraft mission of Voyager 1 and Voyager 2. However, this plan to explore the deepest, most remote and hostile reaches of our solar system would need to capitalize on a rare alignment of the 4 outer planets that would not occur again until the 22nd century. The Voyager missions were only possible because of an extraordinarily fortuitous coincidence that our ability to design, build, and launch spacecraft aligned perfectly with a planetary configuration that would not repeat for another 176 years. That alignment allowed the spacecraft to fly past planets and use the gravitational energy of each encounter to increase velocity and alter trajectory in order to reach the next planet. It was essentially a game of planetary billiards. This favorable alignment in the late 1970s would allow NASA to exploit gravitational assistance to slingshot both Voyager probes from one planet to the next. Harnessing gravity in this way not only reduced the fuel needed, but also dramatically affected the mission timeline. Without the gravitational flybys made possible by this alignment, it would have taken 30 years for the Voyagers to reach Neptune, rather than the 12 years it ultimately took. Although coordinated and directed by NASA, the Voyager program was a highly collaborative venture. with many scientific institutions and university research teams across the US contributing scientific instruments. Launched a few weeks apart in the summer of 1977, the twin probes Voyager 1 and Voyager 2 departed on their one-way tour of our solar system. After 18 months, the Voyager spacecraft reached Jupiter in 1979. The Voyager program truly transformed our perception of the solar system. At Jupiter, Voyager revealed the first active volcanism ever observed anywhere other than Earth, on Jupiter's innermost moon, Io. Distinctive features were identified in the imagery captured during that encounter, and analysis confirmed they were the signature of an enormous volcanic plume rising from the surface of this highly turbulent Jovian moon. It stands as one of the landmark discoveries of the mission. The dynamics of the famous Great Red Spot, an enormous storm roughly the size of Earth, were also studied in great depth. The Saturn encounter was arguably the most visually stunning of the Voyager mission. Voyager delivered an immense level of detail on the planet's ring system. One of the most celebrated discoveries at Saturn was the identification of what became known as shepherd moons, two very small moons moving on either side of the outer rings, whose gravitational influence keeps the ring particles in stable orbits and sustains the ring's existence. Following the encounters at Saturn in 1980 and 1981, the two Voyager probes parted ways to follow very different trajectories. Voyager 1 diverted to investigate Saturn's largest moon, Titan, a highly intriguing and enigmatic world. Ground-based observations had already shown that Titan's atmosphere was rich in methane, which is of significant interest regarding a moon or planet's potential to support life. However, this diversion took Voyager 1 out of the plane of the planets, preventing it from visiting Uranus and Neptune. Voyager 2 continued onward toward Uranus and Neptune. In contrast to Saturn's magnificent ring system and Jupiter's dramatic atmospheric activity, Uranus itself was relatively featureless. The real revelation of the Uranus encounter was the planet's considerable magnetic field, whose structure was highly unusual, shaped like a corkscrew, unlike anything observed in any other planet. This stands as one of Voyager's most significant planetary discoveries. Voyager 2 made its final planetary encounter with Neptune in 1989, the outermost of the gas giants and the most distant planet in our solar system. Neptune came as a complete surprise. The atmosphere was found to be highly dynamic, with a striking blue color that had been hinted at in Earth-based telescope observations. What was truly unexpected was the degree of atmospheric activity, including a dark blue storm closely resembling Jupiter's Great Red Spot, auroral features, and nitrogen geysers on Neptune's largest moon, Triton, which has the coldest surface anywhere in the solar system. So after the relatively subdued results from Uranus, Neptune proved to be a stunning revelation. But Voyager's farewell to the planets was not the end of the mission. On their respective trajectories, it was only a matter of time before both Voyager spacecraft would leave the solar system entirely. In August 2012, 35 years after its launch, Voyager 1 became the first human-made object to enter the region between the stars, known as interstellar space. Voyagers 1 and 2 are now departing the solar system. They are the two man-made objects furthest from Earth of anything we have ever created. They are literally passing through the boundaries of the solar system into interstellar space, which may not sound dramatic if you're accustomed to Star Trek or Star Wars, but to actually leave the sphere of influence of the sun, to leave the place we inhabit in that way, is a fantastic achievement and is the beginning of our exploration of the wider universe. That, to me, is iconic. It is a profound step. It is impossible to overstate the significance of the Voyager mission. Voyager truly put our solar system in perspective. But I think one of Voyager's greatest contributions was how it allowed us to understand our own planet within a broader context, because it is only when you observe the objects around you and see how different they are from Earth that you begin to truly appreciate the formation and the significance of the place we call home. But perhaps Voyager's most powerful and enduring contribution to our understanding of who we are is the family portrait photograph taken looking back at our solar system and its family of planets. Somewhere within that photographic data is a single frame containing a tiny blue dot, partially obscured by a faint beam of sunlight passing through the camera. That blue dot is Earth, and it contains everything you have ever known. Every person, every event, everything that has ever occurred in human history exists within that tiny blue dot. And I think that will likely remain one of Voyager's most lasting legacies. The Voyager program has given us a profound understanding of our place within and beyond our solar system. And in the 40 years since its launch in 1977, it continues to explore and deepen our understanding of where we stand among the stars. Named after the great American astronomer, the Hubble Space Telescope is one of the largest and most versatile scientific instruments ever placed in space. Originally conceived by NASA in the late 1960s, Hubble was built to answer one of the most fundamental questions in astronomy. The Hubble Space Telescope is a one-of-a-kind instrument. It had specific scientific objectives, and one of the most significant was to better understand how far away distant galaxies are, and from that to calculate more precisely how old the universe is. By placing the telescope in Earth orbit, Hubble could overcome many of the limitations of ground-based astronomy and look deeper into the universe than ever before. The telescope was built out of the need to get instruments above the Earth's atmosphere to improve our view of the universe. It is very difficult to conduct precise observations from the ground because the atmosphere interferes. Movement in the atmosphere blurs images in ways that space-based viewing avoids. Being above the atmosphere provides a completely unobstructed view, and the atmosphere also blocks important forms of radiation that astronomers rely on, such as ultraviolet and infrared light. So Hubble gives us access to a much broader spectrum of light than is accessible from Earth's surface. Beginning in 1978, NASA led an international collaboration with the European Space Agency to design and build the most sophisticated space telescope ever constructed. Comprising 400,000 components and 26,000 meters of wiring, Hubble was carried into orbit by a space shuttle in 1990. Close and lock your visors, and you all have a good trip. We are go for main engine start, U, C, San, E, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe. Roll program. Roger, roll Discovery. The telescope was deployed at an altitude of 380 miles, the highest orbit achieved by the Space Shuttle at that time. Your go for HST deploy ops. That's outstanding. Thank you. First glimpse, the Space Telescope looks like it's in great shape. Roger that. Thank you. Now above the distortion of Earth's atmosphere, Hubble would unlock secrets of the universe that no one could have imagined. Hubble has rewritten the astronomical textbooks in so many ways. We have all seen the spectacular images. It has returned regions where stars are being born, the pillars of creation in the Eagle Nebula, supernova remnants showing us what happens at the end of a star's life, and breathtaking images of entire galaxies, island universes containing billions of stars. Ask 100 different astronomers and you'll get 100 different favorite Hubble images. The Hubble Space Telescope has been enormously successful. It was designed for a 7-year mission, and here we are more than 3 times past that. Its very large mirror gives it a substantial light collecting area, which is how it is able to see so deep into the universe. Hubble carries a range of different camera types designed to capture the images we have all come to know and love. But it also carries instruments that record spectra, splitting light into its component wavelengths, allowing scientists to probe deep into distant objects and determine characteristics like temperature and pressure of surrounding gas. Hubble is the only space telescope designed to be serviced by astronauts while in orbit. Between 1993 and 2009, 5 space shuttle missions repaired and upgraded the telescope to keep it at the cutting edge of technology. Because of the shuttle's ability to visit Hubble and both repair and upgrade it, it has been possible to transform a 1970s designed spacecraft and telescope into one equipped with 1990s and 2000s technology. A striking example of this, there was a small patch of sky where, when Hubble launched, not a single star was visible. 7 years later, a new camera was carried up to Hubble, and scientists looked again at that area of space to see what they could find. Known as the Hubble Deep Field, the image captured stands as perhaps the most significant in Hubble's history. The Hubble Deep Field was a very long exposure, the first attempt to look as far as possible into the distant reaches of the universe. Hubble was directed at what appeared to be a completely blank area of sky in the constellation of Fornax. In terms of scale, this patch of sky was smaller than a 1 mm by 1 mm square drawn on your thumbnail and held out at arm's length. Over more than 800 orbits, Hubble observed that same patch of sky repeatedly, accumulating more and more light with an exposure time of nearly 1,000,000 seconds. What emerged were 10,000 distinct points of light, but those objects were not stars, they were galaxies. And a typical galaxy contains around 200 billion stars. For many, this is the most mind-expanding image ever produced in the history of astronomy. The impact of the deep field is particularly striking because you can see faint smudges of light galaxies being born before our own solar system and galaxy even existed. Using that image and high school mathematics, you can make a meaningful estimate of the total number of stars in the universe. And Hubble has confirmed what we've read in textbooks: there are more stars in the universe than grains of sand on every beach on Earth. Hubble's impact has been scientific, but also cultural and profoundly human. The Hubble Space Telescope has been responsible for some of the most detailed deep space imagery ever captured, with many of its observations leading to major breakthroughs in astrophysics. It is difficult to fully quantify Hubble's contribution. In particular, it has helped us determine the age of the universe with a precision we never had before. We can now say the universe is approximately 14 billion years old, give or take. That is a major advance. But beyond that, Hubble has enabled us to study planets orbiting other stars and even examine their atmospheres. We didn't even know such planets existed when Hubble launched. You come to realize two things. First, how vast the universe is, how many stars, and therefore potentially how many planets, and therefore what the likelihood is of life having evolved somewhere out there. And second, how small a part of the universe we are. We assume all knowledge originates here on this planet. Maybe it does, but the probability of something else evolving out there is so much greater now that we know just how many stars exist. When Hubble is eventually succeeded by the James Webb Space Telescope, that instrument will be 1,000 times more powerful. Imagine what we will be able to see from that new spacecraft. I would challenge you to find anyone who is not moved by the sheer beauty in the Hubble images. It speaks to something fundamental in what it means to be human, this deep, innate desire to understand our universe. While other space telescopes exist, Hubble has set the gold standard. Hubble's greatest contribution, I believe, has been to inspire and ignite the public imagination about what lies beyond our world, how thrilling, how beautiful, how extraordinary the universe is, and how humbling it is to sit with images taken from light years away of objects and structures spanning light years across. In a world gripped by its own sharp and divisive anxieties, lifting our eyes to the wonders of the heavens can be a profoundly uplifting pursuit, something to turn to that illuminates an entirely new dimension of what it means to be human. 37 minutes. Whether breaking milestones in human spaceflight or driving deep space research, we have seen how NASA continues to push the bound.